So in this video, I'm going to take you through a few exercises related to direct proportion. The first one is exercise 386 on page 123. And we're asked to decide whether the following relationships are directly proportional relationships, and if they are, give the equation. So then the factor of proportion, k, for example, draw the graph. I'm not going to draw the graph here because I know you know how to do that. You can draw each of the graphs of the directly proportional relationships on the same coordinate system, the same set of axes. You don't need to draw a new set of axes each time for each new one that you have that's directly proportional. So the first one, actually I'm going to do this the other way around to how it asks in the question. I'm first going to develop an equation for the relationship shown, and then I'm going to ask myself, does that represent a directly proportional relationship? Because I think that's the easier way round of doing it. So if I had a square of side length L, and it had, equilateral triangle. I was already doing the next one. And it had perimeter P, how would I relate those two in a function? Well, the perimeter depends on the length. So the length can be our independent variable, and our perimeter can be our dependent variable. And to find the perimeter of an equilateral triangle, I have a triangle with three sides the same length. That's L plus L plus L, which is 3L. So my answer is yes, this is a directly proportional relationship, because it's of the form f of x is equal to k times x. And here k is equal to 3. The second one is very similar. Again, if I did L and P, then the perimeter of a square is just 4 times its length. So P of L is equal to 4L. So here, yes, k is equal to 4. What about the side length and the diagonal of a square? Well, if I had a side length of A, and the diagonal of the square was represented by B, then if I do myself a little sketch, here I have A, B, I could use Pythagoras to find B from A, where I would get A squared plus A squared is equal to B squared. So 2A squared is equal to B squared. So the square root of 2 times A is equal to B. I'm taking the square root here as my equivalency transformation, and normally taking the square root isn't one, but because I know that B and A both have to be positive, it works in this case. Therefore, B of A is equal to the square root of 2 times A. So again we have yes, and k is equal to the square root of 2. Which is surprising. Normally when you have squares and things, we don't even have a linear relationship, let alone a directly proportional relationship. But because we're dealing with geometry, it works. So D, the radius to the circumference of a circle, well, we know that the circumference of the circle, C, is equal to 2 pi r. So I can write that as C of r is equal to 2 pi r. So again, yes, I have here a factor of proportion of 2 pi. So yes, k is equal to 2 pi. The radius and area of a circle, if I call this r and this a, we know that this is a is equal to pi times r squared. Now here, we definitely don't have a linear relationship. Because we have this r squared here, this is not a linear relationship, so it's not direct proportion. So my reason here is it's not linear. Then I have the diameter by the circumference of the circle. So these would be related as C of D is equal to pi times D. So again, yes, my factor of proportion is pi. So actually there's only one that's not a linear relationship and therefore not a directly proportional relationship. The rest of them are. If we'd had any pluses at the end of these with a plus constant, you know in our form f of x is equal to mx plus c, if we'd had any c's here that weren't 0, then also we wouldn't have a directly proportional relationship in this question. So, the next one I want to have a look at is 388F. I wanted to have a look at this one because this one's a little bit trickier than 387A, and I thought if I go through this one, then you should hopefully not have too many questions about 387A if you did anyway. So we have the values of the function f are directly proportional to the arguments, or the x values of the function f. So in here, we're given that f of 30 is equal to 120, and we have to find the equation of this function. We have to draw the graph, which I won't do for you here, but you can definitely do it for yourself, and find f of 2.5 and f of 5. So, first of all, I need to find the equation. Now I know that directly proportional relationships look like this with some factor k. So I know that f of 30 is equal to k times 30, and f of 30 is equal to 120. So I can just set these two things as being equal to one another. So I have 120 is k times 30. If I then divide by 30, I get 120 over 30 is equal to k, which is 12 over 3, which of course is 4 over 1, which means that k is equal to 4. So I have f of x is equal to 4 times x. And that's my solution. If you're asked to find the equation of a directly proportional relationship, all you need to do is find k and write it out as an equation of a function, and then you're finished. So this one's done. The graph I said I'm not going to do, but you should find it goes through the origin and it has a gradient of 4. Every time you go along 1, you go up 4. And my final one is to find f of 2.5. So f of 2.5 is equal to 4, my k, times 2.5, which of course is 10. So that's my first answer. And f of 5 is 4 times 5, which is 20. And there's my answer there. So I've done 388F. Now, I'm going to have a look now at 389F, so the next question. Oh, that is an F, I promise. And that's at the top of the next page, page 124. So we know that the costs, k of x, of a product are directly proportional to the amount of the product. So k of x is the cost of the product, and x is the number of products. And that makes sense. You know, if you buy one apple for 50 cents, that's 50 cents. You buy 2 apples, that's €1, etc., etc. And of course, if you buy nothing, it doesn't cost you anything. So this is quite a normal kind of relationship where we have k of x is equal to k times x. And of course here, k is the cost of one product. Because if I take the cost of 1 times the number that I buy, then I get the total cost. And we had a question similar to this in our first test, if you remember rightly. This is a pattern that comes up again and again. So here we know that k of 10 is equal to 45. We need to find k of 1, k of 15, and k of 55. So first of all, what does this mean? Well, this means that the total cost for buying 10 products, so 10 items, is 45. So the total cost of 10 items. So because I know that this formula holds, I know that 45 is equal to k times 10, where k is the price of one of the items. So this means if 10 of them cost 45, then one of them the price per item costs 4.5. So this means that k of 1 is equal to k times x, which in this case is 1, which is 4.5 times 1, or 4.5. So the cost of one item is 4.5. K of 15 is k times 15, so 4.5 times 15, which is 67.5. K of 55 is 4.5 times 55, which is 247.5. So, that's that one done. The final question on the list is 390. And this is very similar to the exercise that you were shown. So let's take a quick look at 390A. Hopefully I should be able to do this in the time that I have. We're given two sets of coordinates. And we need to check if this describes a directly proportional relationship. If it doesn't, then we need to change the coordinates of B so that it is. And then we need to give the equation and draw the graph. So first of all, is it directly proportional? Well, if we take this one, we know that we have here times 2. So I'm going to have f of x is equal to 2 times x. And of course, that doesn't work for here, multiplying by 2. So I'm going to have b, the coordinates of b need to be changed to 4, 4 times 2, which is 8. So here I've changed the coordinates of b. This is the equation of my directly proportional relationship. And then all you need to do is draw this graph. And it's the same for B, C, and D. They shouldn't take you very long. Just check the relationship between these 2 points, see if it works here, write it as the equation, and draw the graph. If you have any questions, note them down and we can deal with them next maths lesson. I hope that was all clear for you though.